Welcome to Study Loop.
Hello, so to determine the rotation matrix for a rotation of 45 degrees about a y-axis followed by a rotation of 120 degrees about the z-axis and a final rotation of the 90 degrees about the x-axis. So to solve these problems, we'll use the transformation matrices for each operation, okay? And then we're going to supply them to the given points. Okay, so let's start with the transformation matrix for a y-axis rotation about a 45 degrees angle. So we're going to denote our matrix. We're going to call it R of y since it's rotation of the matrix about a y-axis of a 45 degree angle. So our matrix is going to look like cosine of 45 degrees, 0, sine 45 degrees, 0, 1, 0, negative sine 45 degrees, 0, cosine 45 degrees. Okay, so this is y-axis rotation. For our z-axis, let's go in order. So let's do z-axis. We're going to denote our RZ of 120, which is going to equal to cosine of 120 negative sine of 120, 0, sine 120, cosine 120, 0, 0, 0, 1. All right. And now let's look at the transformation for the matrix of x-axis. We're going to denote it as Rx. For 90, which is equal to 1, 0, 1, 0, cosine 90, negative sine of 90. Put these in, okay. 0, sine 90, cosine 90. Okay, so now the overall transformation matrix T matrix for T is going to be the product of these matrices. Okay, and that's going to be T is equal to R times R of X, times our RZ times our RY. Okay? Now, given the second step, given the rotations and the translation, we can rotate 60 degrees about the n-axis. So the steps going to be rotate 60 degrees about the n-axis. Okay, and we have to translate by 4, negative 7. 4, -3, 7. And we rotate 45 degrees about the z-axis. Okay, now with that being said, let's say that let our n be rotated be the rotation about an n-axis denoted as T of n OA be and R of z be the rotation about the z-axis that we specifically said. So what does that look like? So now we can say, so this is the key part right there. And we can say that R of n is going to equal 1, 0, 0, 0 cosine of 60. That's 60. That's going to be 0, negative sine of 60. And we're going to say this is going to be sine of 60. And that's going to be cosine of 60. Okay? So that is what we got. So now, what did we say? We said that T of NOA is going to be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 1, 4, -3, 7, 1. I'm just supplementing the values, okay, guys? All right. So now, what did we say? R of z is going to be equal now to 0, 0 of sine 45 cosine of 45, 0, 0, 0, 0, 1, 0. So if we calculate it, this is what we're going to get, okay? 0, 0, 0, 0. All right. So now the overall transformation of T, right? Let's start that. Overall transformation of T is the product of these matrices, okay? Like before. Okay? Which is going to be equal to T. T is going to be R of z of T and OA times of Rn. Okay? Okay, let me make sure there we go. All right. Good. So now, for the third step, given the rotations and the translation, we can say that the rotation, we rotate 45 degrees about the y-axis. Okay, we can translate again by -3.7. Okay, it's a bracket. Okay, so now we rotate okay, 90 degrees about the o-axis. Okay, so what do we say? So what does that mean? So now we can say let r of y be the rotation about the y-axis, and TNOA be the translation matrix, and R of O that we're denoting be the rotation about the o-axis. I'm writing every single step, guys, just because like it helps kind of see what we're doing. And it also helps me kind of keep track of all the steps that I'm doing. So hopefully it doesn't get too much wordiness and we're following along. Okay, about the o-axis. Okay. All right. So now, what does that look like? So we can say now r is equal to cosine of 45 degrees, 0 sine of 45 degrees, 0, 1, 0, negative sine of 45 degrees, 0 cosine 45 degrees. And T of NOA is going to equal to 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 4, -3, 7, 1. Okay? And our R of O is going to be 1, 0, 0, 0, cosine of 90, 0, negative sine 90, sine 90, and cosine 90. Okay? So for the overall transformation matrix T, okay, overall, start this overall. T is going to be the product, once again, of these matrices. Which is going to be T is equal to R of O times T of NOA times RY. Okay? Now we can apply these transformation matrices to the given points and find their coordinates in the reference frame. and the transformations. Okay? So hopefully that helps.